Ba-da-bum, bum, bum,
Ooh,
bum, bum.
something about the Mars rover. What'd we find? What'd we find? Let's find out. From Inverse, Curiosity finds intriguing carbon signatures on Mars. One potential culprit, ancient Martian microbes. Can we stop calling them ancient Martian microbes? They're just fucking microbes, okay?
Oh, they're ancient and
You know,
they're on Mars, so it's not
uh,
inaccurate.
it's only Martian to us.
Hmm.
Since landing on Mars, NASA's Curiosity rover has been racking up novel Martian discoveries, its newest one could end up being the holy grail of planetary discoveries. The car sized robot recently detected a carbon signature in rock samples from Mars' surface. That same signature is associated with biological processes on Earth and could indicate some form of life on the red planet. But before calling it a signature of life, scientists are trying to understand what else may have been behind the carbon on Mars. Mounting evidence suggests that Mars may have been habitable at some point during its early past, with water on its surface and warmer temperatures. The findings are detailed in a study published Tuesday in the Proceedings of the National Academy of Sciences. Several missions have investigated Mars in search of signs of ancient microbial life, but scientists have not claimed life on Mars yet and are still waiting for definitive evidence to say that there is indeed life beyond Earth. We're finding things on Mars that are tantalizingly interesting, but we need to really, but what we need, but we would really need more evidence to say we've identified life. Paul Mahaffey, the principal investigator of the sample analysis at Mars, SAM, chemistry lab on the Curiosity rover, said in a statement. So we're looking at what else could have caused the carbon signature we're seeing, if not life. Nice.
Yeah.
Nice. Says the rover then
Oop.
used wait. Oh, the rover
Oh, you want
the
me
rover
here, I'll go
yeah,
here.
yeah, right here. Here we go. The
Okay.
rover then used the turntable laser spectrometer (TLS) instrument inside the SAM lab to analyze the samples. The scientists behind the mission heated the samples to about 1500 degrees Fahrenheit to release the gases inside. They then measured the isotopes from the samples and found signatures of carbon. Nearly half of the samples had surprisingly large amounts of carbon 12 compared to the carbon found in Mars's atmosphere. On Earth, carbon is found in all life. Living things on Earth use carbon 12 atoms to metabolize food or for photosynthesis.
Hmm.
There's a huge chunk of the carbon cycle on Earth that involves life. And because of life, there's a chunk of the carbon cycle on Earth we can't understand. Because everywhere we look, there is life. Andrew Steele, a curiosity scientist based at the Carnegie Institution for Science in DC, said in a statement. Where did the carbon come from? Scientists behind the discovery are investigating three different scenarios that may be responsible for the carbon. Number three, the first scenario suggests that carbon may result from ultraviolet light interacting with the carbon dioxide gas in Mars's atmosphere, producing new carbon containing molecules that later settled on the surface of the planet. Lame. Number two, meanwhile, a second scenario suggests that at some point during its early history, about 100 million years ago, the solar system passed through a giant molecular cloud rich in the type of carbon found on Mars' surface. Again, lame. Not as lame as number three, though. And finally, the third scenario, which is number one on their list,
What?
suggests life, the cool one. Scientists believe that ancient bacteria like organisms could have released methane into the atmosphere where ultraviolet light would have converted into that gas into larger, more complex molecules. The new molecules would have rained down to the surface and preserved their distinct carbon signature in the Martian rocks. All three explanations fit the data, Christopher House, a curiosity scientist based at the Penn State, said, and lead author of the study said in a statement. We simply need more data to rule them in or out.
Huh.
So what's next?
So what I wanna know is why you would write a sentence, say they're investigating 3 different scenarios, and then you start at 3.
Yeah, well, three, two, one. I mean, I get what they did there because one is obviously the one that we all want to hear that it is evidence of life on
Yeah,
another
but
planet.
but you'd go in sequence. Is it because it's inverse.com? Are they being clever?
Oh, you see there?
Or
You
is
see what you
that
did
it
there?
might be unintentional, but that is absolutely my because 1, and finally, the 3rd scenario, like,
That's what I'm saying.
that whatever. Sorry.
Yep. You're fine. What's next? Scientists are still trying to understand the carbon cycle on Mars. NASA's Curiosity rover landed on Gale Crater on August 6, 2012, and has been roaming the Martian terrain ever since. The Curiosity rover will continue to measure carbon isotopes on different sites that may also have well preserved rock to see if there are similar signatures elsewhere on Mars.
Hmm.
Curiosity's findings will also help its successor, Perseverance, which landed on Mars in February 2021, search for Martian samples to collect. Defining the carbon cycle on Mars is absolutely key to trying to understand how life could fit that cycle. Steele said, "We have done that really successfully on Earth, but we are just beginning to define that cycle for Mars." Nice.
Yeah, Fictionary. It bothers the shit out of me too. This is like advanced science writing, and they just fucked up the numbers.
Yeah,
That's all I
yeah, they
can
did.
think about now. I don't even like. Okay, maybe life on Mars. Cool, but
Why'd you fuck up?
why'd you fuck up? Oops, you fucked up. Like that's gonna be the thumbnail. Oops, you fucked up. 3, 2, 1. But that's cool. That's great. We find carbon-12. And that's the shit we're fucking up our planet with, right?
Yep. No, that's what we're made of.
Oh, that's what we're made of. Okay. Yeah. Wow. Astronomy and space science. That's my jam right there. I love that shit.
I love astronomy.
I love ass.